2 source transformations, and a Thevenin Equivalent Circuit. That's coming up right now. Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering at your service. In this problem we have, the problem is to show the Thevenin equivalent circuit with respect to terminals VB and VC. So we want to develop a Thevenin equivalent circuit between these terminals right here. Let's use a little highlighter. And I'm going to use a big old little. Here is VB and here is VC. And so these are the two that I'm going to turn this sound up just a little bit. Okay, so in this problem we're going to determine the Thevenin equivalent. We're going to determine the Thevenin equivalent circuit between these two terminals. So what we're going to have to do is a series of source transformations, and then some analysis, and then we'll use the Thevenin algorithm to determine what the Thevenin equivalent circuit is. The first step in this is to do a source transformation. Alright, so the source transformation, as you can see, we have here a power supply. Alright, so the first thing to source transformation is going to be very straightforward. On this one, we're going to let's just scroll up just a little bit. And in order to do a source transformation, it's just pretty much we're going to change this voltage in series with this resistor into a current source in parallel with another resistor. In order to do that, we have the formula, which we're going to put in an I2. Use a different color here, different shade here. So we're going to say I2 is equal to the basically V1 over R1. Alright, so that's going to give us our formula. It's going to be 80 volts divided by 250 ohms. And that says our I2, our new source, is going to be equal to 32 milliamps. Alright, and then of course what's going to happen is this resistor is going to be planted down here. So let's scroll down a little bit and get that. And here's our first source transformation. Alright, so now what we have is these two resistors in parallel, R1 and R2. So that kind of another technique for simplifying the circuit is now we've just taken made one source transformation, and now we can make a second source transformation. Of course, for this one, the let's get there. I'm going to call R12 is equal to 1 over R1 plus 1 over R2, and that's going to be 1 over 250 ohms plus 1 over 8,000 ohms. And I'm not going to sit here and work all this out. If you want to, you should know how to do this calculation right here. This number comes out to, now we're going to have to produce the next one here, is comes out to 242.424 ohms. So it's not going to be a pretty looking picture when we get done with it. So what happens is we combine these two resistors and we get them in parallel, and now we've got our next equation. Okay, so now we have a current source parallel to another resistor, and we can do yet another source transformation here. So in order to move forward on this, we need to simplify the circuit a little bit more. And the second source transformation, that's going to be V2. So we're going to call the second power supply is going to be V2 instead of the V1 that we had before. It's just equal to I2 times R12, and that's
going to come out to, let's see, I2 is 32 milliamps times 242.424 ohms, and that number comes out to let's see, V2 77. I got to quit losing that thing. Alright, 77.576 volts. Okay, so our resistor stays the same. Of course, now you see here we have R12 right here in series with R3, which was there before. So here again we have a simplification that we can do on our circuit, and we combine those two resistors in series and produce our next one. Okay, here's our next. Let's stop doing that. Okay, here's our next schematic. So now we have a resistor R123, which is just.
Thanks for watching my program. If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.